Yes, signalan mo ako anak ha. Okay na. Okay, may link. Ay, net, sandali nga. Huwag mo muna ikakasa. Kailangan pala i-drawing ko muna yung circuit. Di pala na i-drawing. Wait lang, na-drawing. Okay, good morning. Good day to everyone. So this is Engineer Reggie Marinay of the Marinay's Powerhouse Team Review and Training Center. Good day to our students and to all our, actually we are on a live stream in YouTube. Welcome everyone. There are students here in the Philippines and also those who can watch this lecture on a live stream, no? Whether you are a Filipino, an American, a European. So whoever you are, no, especially if you are an electrical student, electrical engineering or electrical technology student, so this is a lecture for you. Okay, so we'll be discussing about the part 2 of the series and parallel circuit. Okay, so let us start our discussion. So calculate the effective resistance of the following combination of resistances and the voltage drop across the 3 ohm resistance when a potential difference of 60 volts is applied between points A and B. So take a look at our given. So I already draw the given here. So we have a circuit, we have a 3 ohm in parallel with 6 ohm, and then we have an 80 ohm resistance here, 8 ohm, and then we have a 5 ohm resistor. Okay, so we have here, it says in the problem here, when a potential difference of 60 volts is applied between points A and B. So we have points A and point B. So basically, this is our 60 volts. Okay, this is the positive terminal, this is the negative terminal. Okay, let's read again the problem. Calculate the effective resistance of the following combination. So the question is the effective resistance. So R total, that is the unknown. And the voltage drop across the 3 ohm resistor. So, the voltage drop across the 3 ohm resistor. Okay, so that is the question. No? When potential difference of 60 volts is applied between points A and B. So, we have here 60 volts applied between points A and point B. So, this is our source voltage. No? We can find first our total resistance. Okay, so we can see here that the 3 ohm resistance is in parallel with the 6 ohm resistance. So we can have here 3 ohms in parallel with the 6 ohm resistance. So that is simply equal to the product over the sum. So we have 3 times 6 over 3 plus 6. Okay? Okay, so 3 times 6, we have 18. Then 3 plus 6, we have 9. So therefore, we have 2 ohms. We have a 2 ohm resistance here. Okay, so we have here an 18 ohm resistance. So take note that we have an equivalent circuit here. Okay, so the value is 2 ohm resistance. This 2 ohm resistance, there will be an equivalent circuit, no, that is connected in series with our 18 ohms. Okay, so if this is, the equivalent is 2 ohms, okay, then that is connected in series with the 18 ohm resistance. So 2 plus 18, so that will be 20. So I will put here the 20. Okay, I'll show this to you guys. So we have here the 2 ohm resistance. This is the 2 ohm resistance. Then we have the 18 ohms. Okay, then still we have our 8. This is 18 ohms. And then we have here our 5 ohm resistance. Okay, so we have here our 8 ohm resistance. And then, of course, our source voltage here. We have the 60 volts resistance. So take a look here, guys, that we have our resistance. So this is 18 over 9. So we have here our 2 plus 18. So we have here 20 ohms. Then let us get the equivalent. So we'll be having here a parallel circuit here. Okay. So we have 20 ohms. We have the 5 ohm resistance. So let us calculate the 20 in parallel with 5 ohm resistance. Of course, again, there will be 2 parallel branch. So we have here the product over the sum. So 20 times 5 over 20 plus 5. Okay. So we have here 20 times 5. So we have here 100. Then 20 plus 5. So we have here 25. So we'll come up with 4 ohms resistance. So this is our 4 ohm resistance. Okay? So there will be an equivalent circuit like this one. So this is our 4 ohms. Okay? And then we have here our 8 ohm resistance. Okay, then this is our voltage source. Okay? So we can now get easily our total resistance here. Okay, the total resistance. Okay, so this will be our total resistance. Take a look here. We have here 4 and 8. Okay? 4 plus 8, so we'll be having here 12. So 4 plus 8, because they are connected in series. So we have here 12 ohm resistance. Okay? So, nakaseries silang dalawa. Ipa-plus lang natin, di ba? So we have here 12 ohm resistance. Okay, so this is our total resistance. Then there is another question. What is the other question? Take a look again. So we have the voltage drop across the 3 ohm resistance. Here, the 3 ohm resistance. So we have the 3 ohm resistance. Take a look. So we have to find the current flowing in the 3 ohm resistance. Here. Let's say this is current I. We're asked to find the voltage drop across this. Let us find I. Now, we have here the I total. Okay? Always, the I total is the current that will be supplied by the source. That is our I total. So, we have here I total, that is by Ohm's law. I total, that is simply equal to the total voltage, which is 60 volts, over the total resistance, which is 12 ohms. Okay, so 60 over 12, so that is 5 amperes. So there is a 5 ampere flowing here. That is our total current. Okay? Then let's say, let us put a current here. I will name this as I sub 1. So by current divider theorem, what is our I sub 1 equal to? By current divider theorem, so our I sub 1 is equal to what? This is our I sub 1. Okay? That is equal to, so I sub 1 is equal to the resultant current. What is the resultant current? Okay? The resultant current is our IT, which is 5 amperes. 5 amperes. Okay, so we have our I1 is the resultant current, which is 5 amperes. And multiplied by the opposite resistance of I1. What is the opposite resistance of I1? That is the current divider theorem. Opposite resistance is 5 ohm. Yung katapat na resistance, no? Doon tayo titingin, ha? So we have here 5. The opposite resistance, we have here 5 ohms. 5, then over 5 plus, then what is the resistance of this? 20 ohms. Okay? So let us calculate our I sub 1. What is our I sub 1 equal to? So we have here 5 times 5, then divided by 25. Of course, this is just simply 1 ampere. Okay? 1 ampere. That is our I sub 1. That is our I sub 1. Okay? I sub 1. Where is this I sub 1 on the original given circuit? On the given circuit. This is our I sub 1. Take a look here. The I sub 1 is the current flowing in the 2 ohm resistance. Okay? So I sub 1 is the current flowing in the 2 ohm resistance. And the 2 ohm resistance is the combination. That is the parallel combination of 3 and 6 ohm. Right? So, we have here I sub 1. This I sub 1 actually, A. This is our point A. Take a look this first. There will be 2 current flowing. No? The input current is our I total. Then our output current or the current that will lead through point A is I1. Let's say, let us name this as I2. Let's say this is our I2. The current in the 5 ohm resistance. Okay? So first, where is that I1 and I2 in the original circuit? Take a look. This is our I total. That is our I total. So this will be our I1 and this will be our I sub 2. Okay? Then, take note, there is I sub 1 here. And the I sub 1 here is the resultant current of the 3 ohm resistance. The current here I, we can get now I from the circuit that is equal to the resultant current I1, which is 1 ampere, and then multiplied by, okay, multiplied by what? The opposite resistance. The opposite resistance. This is just simply I, ha? I lang to. I. Okay? Is equal to the resultant current, I1, which is 1 ampere, multiplied by the opposite resistance of 6 ohm. 6 ohm over 6 plus 3. You have to add the two parallel resistors. 3 plus 6. 3 plus 6. Okay. Let us get now our current. What will be our current? Okay, 1. So that will just become 6. So that is simply 6 over 9. That is 2/3. Okay. That is 2/3 of an ampere. The question is, what is the voltage in the 3 ohm resistance? So the voltage is just Ohm's law. So we have here, voltage in the 3 ohm resistance is equal to 2/3 ampere, simply IR. Okay, so 2/3 and then multiplied by the 3 ohm resistance. Okay, the 3 ohm will just be cancelled out. So our answer for the voltage drop through the 3 ohm resistor would be 2 volts. That is the answer. Okay? Okay, for number 1, we should have 2 answers. We have here 12 ohms and we have 2 volts. Okay, what letter is our answer, guys? So, please take a look. Okay, the answer would be letter B. Okay, that's the answer. Nakuha ba mga kawerpa? To all our Filipino audience. Okay? Na-gets po ba? Nakuha? Okay. Sige, naririnig po ba ako ng maayos sa inyong lugar? Sino po ang hindi maayos ang rinig? Naririnig po ba? Okay, sige, thumbs up naman kayo, no? Magsabi lang kayo, ha? Mag-raise hand lang kayo pagka hindi maayos yung, ano. Pag nakita namin, majority hindi maayos. Ibig sabihin, may problema sa amin, no? Sa signal namin. Okay. Let's go on to number 2. What happened? Okay. So, number 2. There is a potential divider shown. Oh, by the way, I have to draw first, no? The figure. So, there is a potential divider. I will draw the potential divider. Okay. So this is the given for our potential divider. We have 110 volt source here. Then our potential divider is 24 ohms, no? The whole resistance is 24 ohms. Okay. Then we have a 40 ohms resistance here. Okay, so that is the given. Okay, so let us read again the problem. The potential divider shown has a resistance of 24 ohms and is connected across 110 volt supply. What will be the current through the 40 ohm coil? So that is the question. What will be the current through the 40 ohm coil? So the current here. Let's say that is current I. The current through the 40 ohm coil. When the sliding contact X, where is the sliding contact X? This is the sliding contact. Okay? So you can slide here over the contact of the 24 ohm resistance. Okay? So this is the sliding contact. What will be the current through the 40 ohm coil when the sliding contact X is the 1/4 of distance from A to B? Okay, where is from A to B? So this is the whole 24 ohm resistance. Okay, that is the whole. Question, what is the value of X here? Our X, take note, no? Okay. When the sliding contact X is 1/4 of distance. 1/4. So let us get our R dx. What is our R dx? It says here, when the sliding contact X is 1/4. So put here 1/4. And then multiplied by the whole resistance, which is 24. So 24 divided by 4, so we have here 6 ohms. Okay? So we have a 6 ohms, the resistance between from B to X. This is 6 ohm resistance. Okay? Of course, 24 minus 6, how much? We'll be having 18. Okay? 18. Okay. I will redraw the circuit. I will redraw the circuit like this one. It will be, so that it will become a series parallel circuit. This will become a series parallel. Okay, again, we have here 24 ohms. We have here 40 ohms. Then we have here the 6 ohm resistance. 6 ohm. Of course, we have our voltage source, 110 volts. Then our current here is current I. First, we have to get our total resistance. Our total resistance is very easy. How's that? That is just the combination of these two in series with this. Okay? We can go directly to our total resistance. Our total resistance, this is a series parallel circuit. So we have here 24 ohms. Put here 24. 24. Then plus the product over the sum. So 40 times 6. 40 times 6 over 40 plus 6. Okay? So, what is 40 times 6? 40 times 6 divided by, that will become 46, equals. Okay, then we have to add the 24 plus 24. So the answer would be 29.22. 29 here, 22. 29.22 ohms. That is our total resistance. Then we can get now our total current. This is our total current. That is always the current that will be supplied by the source. Directly coming from the source. That is our total current. So the total current simply equal to the total voltage, 110 volts, okay, over total resistance, 29.22. So how much is this? Okay, so we have 110 divided by 29.22. So the answer is 3.76 amperes. Okay, 3.76 amperes. That is our total current. Take a look by current divider theorem. Okay, so our current I simply equal to the total current, again, multiplied by the opposite resistance, which is 6. That is the opposite, yung katapat, no? Yung katapat na resistor. 6 over 6 plus 40. So we just have to substitute the 3.76 here. We already get 3.76 as our I total. 3.76, then times 6, then divided by 46. Equals the answer. Okay, let us double check, ha? Double check natin. Oh, by the way, sorry. I have to make a correction here. This should be 18. Kasi ibabawas mo nga pala itong 6. So that should be 18. Okay? So because this is the contact, no? 18 plus 6, that is our 24. So I have to correct this. Okay? I will make this as 18. So therefore, the answer here, may I correct this? So that is 40 times 6 divided by 46 equals then plus 18. So 23.22. 23.22. So put here 23.22. 110 divided by 23.22 equals. That is 4.74. Okay, so let us just substitute the 4.74 here. Okay, that is times 6, then divided by 46 equals, there you are. My answer here is 0.06, 0.618 ampere. Okay? So So that will be our value, final answer. Okay? Let's take a look. That will be letter, okay, letter A. Okay, nakuha ba mga kawerpa? Nakasunod po ba? Tanong, baka may tanong kayo dyan. Okay, nagkamali lang po ako doon, ano? Dapat 18. Hirap ng live. Okay, ha? So, we are on a live broadcast. Okay. Sige, so let us continue. Okay. Maybe you can copy first, no? Pakita muna natin to para makopya nila. Baka may kumokopya. Because I will draw the next circuit. Ito na lang. Anyway, you can watch this over and over again, no? So you can repeat watching this lecture because we will be uploading this lecture later. Once we finish, we'll upload this in YouTube. Okay. Actually, we have another potential divider. Okay, let us read the problem. A potential divider of resistance 120 ohms. So, the value is 120 ohms. Is connected across a 100 volt supply. So, this is 100 volts. Okay. 100 volt supply. A current of 2 ampere is required in the 10 ohm coil. So, where is the 10 ohm coil? That is our load resistance here. Okay. Again, a current of 2 ampere is required in the 10 ohm coil. So you need 2 ampere here. 2 ampere. So find the value of the resistance AX. By the way, where is AX? Okay, so this is point A and this is our point X. This is our point B. Okay. Again, what is the question? Find the value of resistance AX here. So this will be our, well, I will just make this as R. Understood to be that R is the resistance at AX. Okay? Again, take a look here. So we have here, a 120 ohm potential divider. This is, okay, a variable resistance, no? So we have here just like what we did before. So let us break down this potential divider into two. Okay, let us represent this as R. And then we have our 10 ohm resistance here. Okay. Okay, there you are. So we will form again a series parallel circuit. This is the 100 volt source. Okay. So if this is 120, this is 120 from point A to point B. Okay. What will be this one? So that is 120 minus R. Isn't it? Minus R. Because from point A to point B is 120. You have to subtract. No? Ibabawas mo tong resistance para yun ang value nito. Siya bali yung Bx. Okay, nakuha po ba yun? Okay, so ganun ha. Ito siya. Okay. We already have a 2 ampere here. 2 ampere. Take note, may 2 ampere na kagad tayo dito. 2 ampere na yan. We can have our total current here. Okay, that is our total current. Okay, so we have here our 2 ampere here. Okay. Take a look here. We have 120 minus R that will be in series with the parallel combination. Okay. Let us get our total resistance here. Okay, so we have our total resistance. What is our total resistance? We have this 120 minus R. Okay. That should be plus the parallel combination. Okay. What is the parallel combination? So we have the product over the sum. So R times 10. Okay. Or simply 10R over R plus 10. So that will be our total resistance. That is our total resistance. 120 plus R times 10, the product over the sum. No? The product over the sum of the two parallel branch resistance. But what is our I total? What is our I total? Okay. Take a look here. I total is equal to V total over R total. Okay. We can have here also this approach for our I total. Our I total is what? What is our I total? The voltage at Bx. The voltage at Bx. Anong voltahe dito? The voltage here divided by the resistance. 120 minus R. But what is the voltage Bx? We can already calculate the voltage at Ax. What is voltage at Ax? That is simply equal to 2 times 10. So 2 times 10, so that is 20. 20 volts. So therefore, if you have 20 volts here, 20 volts, so this is 100. So 100 minus 20, this will become 80 volts. Isn't it? This will become 80 volts. 80 volts na lang yung voltage drop dito sa Bx. That is 80 volts. So therefore, our I total will be 80 volts over 120 minus R. Isn't it? That is our I total. Then, how to get our I total and R? There should be two equations. By current divider theorem, okay? By current divider tayo ha. Yung 2 ampere natin, that is equal to what? Our 2 ampere is equal to what? I total, okay? What is our I total here? 80 over 120 minus R. Okay? Then, multiplied by, okay, this is our I total, multiplied by the opposite resistance, which is simply R, over R plus 10. So, in here, there is only one unknown. So, in our calculator, this is very easy. You just have to shift solve this. Input mo lang sa calculator mo to. Replace mo lang yung R ng X, no? Okay? Well, if you don't have that calculator, you have to manipulate it algebraically. Okay? So, let us do this in our calculator. We have 2. We have 80, 120 minus R. Okay? Happen. Okay, my answer here is 24. Take a look here. I hope you can see in your monitor. So that is around 84.244. Okay? So that is letter C. Okay, that's the answer. 84.24. 0.24 ohms. Okay? Okay, that is the value of our resistance R here. Okay? Okay, are there any question, guys? Are there any question? May tanong po ba, Mr. Garcia? Sir Garcia, may tanong? Pakita nga natin sila. Ano?
Sir.
Sige, sir. Sige, sir. Bago tayo pumunta sa next.
Did we get the 84.24?
Yes, sir.
Okay, didn't get it. I have different answer.
That's wrong, sir. The answer in the book and my answer is 84.24. You double check. Did you arrive with this equation? Actually, this is already the equation.
Yes. Yes, sir.
So you just have to input this in your calculator.
2 equals
Okay?
80, 120
Sino nakakuha rin ng 84.24? Shift solve lang po ito. Sino po nakakuha? Taas nga ang kamay. Ayun, nakuha ni Leo, sir. Parehas kami ni Leo. Sino parehas kami sa 84.24? Kung nakikinig kayo dyan. Ayun, si pwede bang sino yan? Si CK, pwede ka bang mag-open ng camera kasi requirement natin. Kung hindi namin kayo may consider sa attendance for today. Requirement po ang bukas dapat ang ating camera. Okay, hindi ba tayo posible mag-open? At saka sino isa? Ricky ba yan? Si Ricky. Paki-open naman. Okay, Ricky, pares ba tayo nung nakuha? O, yun, sir. Sir Garcia, may problema. Ayun, alam na ni Sir Garcia. Okay, sige, punta na po tayo. Okay, ha? Para hindi tayo masyado magsayang ng oras kasi 10 items to, pero mahaba yung solution. Okay. Sige, punta tayo sa number 4. Everybody, no? So please follow, no? Also, baka mamaya mali na pala yung tinuturo ko sa inyo, di ba? Dapat nagche-check din tayo, no? See for yourself, ha? Baka mamaya niloloko ko na kayo, no? Mas maganda yung tayo open, no? Yun ang kaibahan nitong ginagawa natin na to. Okay. So, we have number 4. Biro mo, 3 item pa lang, oh. Halos mag-iisang oras na tayo. Okay. So, a potential divider of resistance of 50 ohms is connected across, I think I have to consider the picture. I don't have the drawing. So, okay. So we have a potential divider. I will draw this one like this. I have to draw first. Potential divider of resistance 50 ohms. Doon muna tayo. 50 ohms is connected across 100 volt supply. 100 volt supply. A load resistance of 10 ohms is connected across the top in the potential divider. So meron daw tayong 10 ohms. Nakalagay dito. Okay? So we have 10 ohms across the top and the negative terminal. If the source of the source, if a current of 4 ampere flows towards the load. Okay, so where is that? Here. That is the load resistance. So meron tayong 10 ohms yan, ha? 10 ohms. Yung potential divider natin, our potential divider is 50 ohms. So this is 50 ohms. Take a look, ha? The 100% resistance of this is 50 ohms. Okay? What is the current supplied by the source? Well, that is the question. What is the current supplied by the source? Current supplied by the source, no? Yan ang hinahanap sa problem natin. Okay. So, we'll be having here an equivalent circuit like this. Okay? Everybody, sundan ninyo ako, ha? Okay. So, hinati ko lang tong potential divider. I will just divide this into 2. Not actually 50% and 50%? Not necessarily. We have to satisfy the condition here. So, we have a resistance here, 10 ohm resistance. Then we have, let's say this is our R. That is one unknown. That is our R. Okay? So, if this is our R, how do we represent this resistance? This resistance is simply 50 minus R. Isn't it? Ito, bali 50 minus R na lang to. Remember that we have a 4 ampere current here. Okay? 4 ampere current. So, we have here a 100 volts resistance. We have here our total current. Current supplied by the voltage source. Okay? Now, what is the equation for the 4 ampere? By current divider theorem, the 4 amperes is simply equal to the total current IT. Remember this, no? This is our IT. Okay? IT. What is our IT here? Okay, just put here first our IT. Okay? IT. And then multiplied by, so this is the 4 ampere, again, multiplied by the opposite resistance, which is R, over R plus 10. Isn't it? By the way, guys, what is our IT equal to? What is our IT? Take a look that IT is the current flowing in the 50 minus R resistor. Yan yung kuryente dito sa 50 minus R. Okay? So, ito siya. This is the current IT. What is the voltage in the 10 ohm resistance? Which is also the voltage in the resistance R here. It's simply, if this is 10, this is 4. So, 4 times 10, that's 40 volts. That's 40 volts. This is, if we have a voltmeter here, that is 40 volts. Of course, what will be left here? That is 100. That is 100 minus 40. We'll come up with 60 volts here. Okay, makinig mabuti. Medyo mahirap ito, makinig. Okay. So, our IT now is what? Take a look here. I will substitute, guys. 4, that is equal to I total. Again, what is our I total? Ohm's law. 60 volts. Okay? The voltage over the resistance. 50 minus R. Multiplied by, okay? Again, we have here our R, then over R plus 10. Okay, so just shift solve. Or you can manipulate it algebraically, but that is too long. We can make it in our calculator. We can make it with you, calculator. Okay. So we have 4 alpha calc, then we have here 60. So over, that is 50, then alpha, close parenthesis. Oops, that should be minus. Okay. So we have here alpha, close parenthesis, then over, alpha, close, then plus 10. You set up this equation in your calculator. Come on. Okay. Okay, then shift calc equals. Remember, the question is, what is the current supplied by the source? Okay, so antayin lang natin at medyo na traffic yan. Traffic sa Pilipinas. Okay, so the answer here for our R is 38.12. But that is not the question. The question here is what is the current supplied by the source? Current supplied by the source is our IT. Okay, so IT po yan. So, IT, it will be, again, we said here, IT, this is our IT, that is 60. Okay, in this equation, take a look, this is our IT, 60 over 50, 50 minus R. By the way, this is a board exam problem. This is a licensure exam problem. So please listen. So just substitute in here. Okay, this is 50 minus 38.12. Okay. Now, give me the value here. Come on. So this is 60, then divided by, so we have here 50, then minus 38.12. Okay, the answer would be 5.05. Okay, that is the answer. Okay? And that would be letter. What letter is this? Okay, that is letter B. Okay, that is letter B. Next number 5. Okay, we already have a circuit for number 5. Take a look. The circuit shown is connected across the 100-volt source. Supply R2, that is 22 ohms. And R3, this is our R3, is adjustable. This is adjustable. Let's say a potentiometer. With R3 open circuited. Oops, this becomes open circuited. You remove R3. Okay? That is open circuited. The voltage across R1 is found to be 45 volts. When this becomes open circuited, 45 volts here. So find the value of R1. So what is the value of R1 here? Okay? What is the value of R1? Okay. So if this is open circuited, what can we say about our circuit? Okay, so we have here our R1. We have here our R2. This is our R2. Okay. Our R2 is 22 ohms. 22 ohms. So we have here our R1. Okay, again. R3, it says in the problem. Let's go back again here. R3 is adjustable. With R3 open circuited. So I already removed our R3. The voltage across R1 is found to be 45 volts. So, meaning there is a 45 volts here. Okay? That is 45 volts. Find the value of R1. So, this is the question. Okay? So, that is the question in this problem. Okay? Take a look here. We have here our total resistance. What is our total resistance? Simply equal to R1 plus 22. Okay? R1 plus 22. Then, what is our total current? Remember, we have here a 45 volts resistance here. There is a total current flowing from the source. This is a total current. This will just become in series, right? Okay? You may remove these wires. Okay? So that you will not be confused. Okay. That is just connected in series. See? They are just in series. That is why I just put here R1 plus 22 ohms. Okay? Because R3 is already open circuited. But we have a total current flowing. There you are. That is the total current. By the way, let us get our total current. What is our total current? Total current is equal to what? Total voltage. What is our total voltage? 100 volts over total resistance. R1 plus 22. R1 plus 22 ohms. Take a look, the 45 volts is equal to Ohm's law. I total, which is 100 over R1 plus 22. I total times R1. Because this is our I, then this is R1. Okay, there is only one unknown here. So just shift solve in our calculator. So we have here 45, then alpha calc. Okay, we have 100 over alpha close parenthesis, then plus 22. That is times alpha x. Shift calc equals. The answer is 18. 18 ohms. Okay. Is 18 in our choices. Let's take a look here. What letter is our final answer? Come on. Okay. Oh, what happened to our animation? Actually, the answer is 18 there. No? Mali lang po yung animation. Mali lang yung lagay ng animation. It is 18. No? 18. Okay. So R3 adjusted, so that is open. Actually, there is a follow-up question here. May follow-up question tayo sa number 6. Okay, for number 5, okay, to our non-Filipino audience, no, the answer here is 18 actually. Of course, before I teach this, I already solved this. Okay? I already cooked this. For me, teaching is like cooking. Before you prepare to your loved ones. Because I love my students. No? Before you, ang hirap Englishin, ano? Bago mo ihain yung pagkain, lulutuin mo ng masarap yun eh. Di ba, no, Sir, si Sir Narciso, di ba, Sir Narciso, tama ba ako? Dimbawa, sinigang na baboy, di ba? In the Philippines, one of the most delicious food is the sinigang na baboy. What's that in English? And also one that is the chicken adobo. Okay? One that is chicken with soy sauce. Okay. So teaching for me is like cooking. I remember when I was teaching in UE Caloocan, there was a writer in our newspaper being published weekly. Okay, that's what we call the Dawn, Sulweta. Okay, the Dawn. Okay. They asking me, what is teaching for you, sir? Because that day is, they call that Teacher's Day. For me, teaching, my co-faculty answered this very serious answer. They give a too long answer. Then they shock with me because my answer is different from their answer. For me, teaching is like cooking. Huh? You have to cook first before you give it to your loved one. Okay? I already solved this, so it's just that the choices, no? We just had na mali lang doon sa animation. There are just an erroneous in the animation of the PowerPoint. Okay, from time to time, please bear with us, no? But don't worry, I'm sure that the answer here is 18. In fact, there is an additional question to verify. Okay, to what value must R3 be adjusted? So, i-adjust daw natin to. Ano daw value na i-adjust daw natin to? Must, to what value must R3 be adjusted in order that the voltage across R1 may be 60 volts. So, i-adjust daw natin. So, gagawin daw nating 60 volts yon. Okay. So, here we have to make adjustment here. So, this is our circuit, guys. Okay, I will use the 18 we calculated. We calculated 18 ohms. Okay? And then, we have here R2, this is R1, then R2 and R3. Then we have R3. Okay? Then we have a potential, let's say potentiometer, the variable resistance. We have our 100 volts here. Okay? It says in our problem that to what value must R3? So ano daw yung value nitong R3? Must R3 be adjusted in order that the voltage across R1 may be 60 volts. So this will become 60 volts. The voltage across R1 is 60 volts. Then take a look here, guys. Take a look here. By the way, this is 22 ohms. Okay? That is 22 ohms given yan. So, 60. Okay? So, this is 60. The source is 100. So, we'll be having here 40, isn't it? Okay? Nakasunod ba doon? So, madali lang, no? So, that is 60 plus 40. That is 100. Okay? So, I use the 18 ohms here, the one we calculated, to prove to you that this is correct. Okay? So, this is the question here, what is our R3? What is our R3? Okay, what is the current in the 18 ohm resistance to our R1? That is our total current, right? That is the current from the source. So our total current will be equal to what? Okay? 60 volts. So 60 volts ito, no? So this is 60 volts, then divided by 18. Okay. So we have 60 divided by 18. Okay, that is 3.33. 3.33 ampere. That is the current here. Okay? $3.33. Now, take a look here. What is the current here? I will make this as current I. Simply current I. What is our current I? That is the current flowing through our 22 ohm resistance. Remember, if this is 40 volts, the voltage here is also 40 volts, right? Because they are just simply connected in parallel. So we have here 40 divided by 22. So that is equal to equals 1.82. Round off natin, no, 2 decimal places. 1.82 ampere. So, the current here is 1.82 ampere. The current I is 1.82 ampere. Now, take a look here. I'll just use the space here. We have 1.82. That is equal to what? By current divider theorem. I total. What is our I total? That is 3.33. Multiplied by the opposite resistance. What is the opposite resistance? R3. Over R3 plus 22. So there's only one unknown. Shift solve. What is our R3? My answer here is about 26.5, 0.52, 26.52 ohms. That is my answer. Okay? You can see here that I use the calculated value before we have 18 ohm. I use the 18 ohm resistance here. Okay? To prove to you that 18 ohm is correct. Okay, what is the letter of our answer? Take a look here. In the licensure exam, just choose the nearest value because there will be a bit, sometimes there is some discrepancy or differences in the final answer. Just a little. Well, of course, there's no other than letter A. That is the nearest because that is already 33, 72, and 45. No? That's very high, very big difference, no? Especially these two. Okay? The answer would be letter A. Okay? Are there any question to our Filipino audience in the Zoom class? If there are any non-Filipino watching us, you may join to our Zoom class. No? You may join with us so that you can also ask questions. If you want to clarify something, that is one advantage if you will be joining to our Zoom class. So this is a virtual classroom, no, that we made. This is via Zoom and by other software so that we can do this and you will feel that you are in an actual class even though you are at home. Okay? I think up to now we are the only one doing this kind of lecture on the air on YouTube. Okay, anybody who would like to ask question? Sir Garcia, may tanong po ba tayo? Nawala si Sir Garcia. Leo, can you follow dyan sa lugar mo, Leo? Nakasunod naman si Sir Narciso. First time po ba natin, Sir Narciso? Nakasunod po ba? Ano ba yan? Picture ba? O na-stack up si Sir Narciso? Si CK ng TIP. Technological. Nakasunod ba, CK? Anong year mo na? Sige nga, kausapin natin para makita ng ating mga nasa YouTube na live tayo, no? Na ginagawa natin to. May I hear from you, CK? Is this your first time to join in our Zoom class?
No, sir. I've been
Natin.
registered last week, sir.
Okay, pakilakas. Do you have any question regarding are you getting the discussion? Can you follow my my way of delivering the lesson?
Yes, sir. Po.
Okay, is that clear for you? Is it clear for you?
Yes, sir. It's very clear.
Okay, you have no more question? No question?
I don't have questions, sir.
Okay, thank you, CK. What about Aris? Aris, are you there? Where's my friend? Aris, nasaan ka? Nandiyan pa ba si Aris? Nasa trabaho kasi si Aris Ricky, what about Ricky Riveza? Ricky, hello Ricky. Hindi natin marinig si Ricky. Okay, i-unmute natin si Ricky. Unmute natin. Yan, naririnig na kita. Ricky, baka may tanong ka, Ricky. Kasi magandang nakikita ng ating mga viewers. No? Are there any question?
Okay naman, sir. Nakakasunod naman, sir.
What? What did he say? Can you follow? Okay. Do you have any question, Ricky?
None, sir. None, sir.
Okay, what about, nandiyan na ba si Sir Garcia? Ayun kanina si Sir Narciso. Hello, Sir Narciso. Do you hear me, sir?
Yes, sir. Yes, sir.
Okay, nakakasunod naman ba sa ating discussion?
Opo.
Nakasunod naman. Baka may tanong ka. Do you have any question?
Yung pong
Okay.
sa calculator.
Can you speak in English because our medium here is English? We are anticipating in the near future we have a non-Filipino audience.
So,
Because our dream is, one of our dream is to encourage the non-Filipino electrical students to come in, to join with us in our Zoom class. That is one of our dream, no? Is that impossible? Well, if that is impossible, let's call this as an impossible dream. Okay? So,
what kind
yes,
of
Narciso, any
calculator
question?
what kind of calculator you use in computing the solution?
Pakilakas.
What kind of calculator are you use?
What kind of calculator? Okay. What is your course? Are you engineering graduate? What is your course?
No, I am only a NC3.
Okay. You're not an...
Uh,
okay. So we are using the Casio. Actually, I am using the 991, the old one. But this is just the same with the Casio, the latest Casio of 570 ES+. If you want to take the licensure exam for master electrician, you may use, it's the best if you will use the Casio 570 ES+. The 570 ES Plus is just like this one. The difference is only is this one, the what do you call this? The solar power here. It's just the straight color gray for the 570 ES Plus. But nowadays, in our country, what you can buy now is the second edition. Then that is allowed by the Professional Regulation Commission. Okay? Well,
okay, thank you.
this is actually this is a third year level way of teaching. Well, if you are already in third year in electrical engineering, we are considering that you already know algebra, no? And then a little calculus later on. Okay? So, it is actually, it needs a good foundation in algebra. If you want to manipulate this manually or semi-manual, no? Okay? But if you have this calculator, it's really very, very easy.
Very easy. Very easy.
Okay? Because this is allowed by the PRC. Again, ang allowed ng PRC, yung 570 ha, ito hindi na allowed eh. Actually, isa lang yung manual niya. Parehas lang. Ang difference lang, solar panel. Nagtataka nga kami, bakit hindi ito inallowed ng PRC na eh. Since 2010, allowed to eh. Ngayon, hindi na allowed. Pero ang allowed, yung kamukha niya, yung kapatid niya. Ang kapatid niya, si 570 ES Plus of Casio. See? This is Casio. Nagtingin ako kahapon sa supplier, nagkakaubusan eh. Problema, nagkakaubusan nung 570. Still, waiting pa ako. No, kaya wala munang although we are selling that, but nagkakaubusan. Di muna ako magbebenta. Antayin pa namin yung supplier. No? Okay, sige. Okay, let us continue. Okay, for our first timer, to our Filipino friends, audience, I am using the English language, no? But don't worry, no? My English is just an elementary English. No? It's so easy to understand, no? So it's not a deep English, okay? So please listen carefully, okay? Next problem. Okay, for problem number 7. A 5 ohm resistance is connected in parallel with 10 ohm resistance. Okay, so we have here a 5 ohm resistance. 5 ohm resistance is connected in parallel with the 10 ohm resistance. Another set, a 6 ohm and 8 ohm resistance are also connected in parallel. The two sets are connected in series. Okay. I think this is an easy problem. Okay, so another set, 6 ohm and 8 ohm resistances are also connected in parallel. The two sets are connected in series. What is the equivalent resistance? The equivalent resistance is this. Let's say you have an ohm meter to measure the equivalent resistance. You have a tester. What is the total resistance? This is an easy question. We'll be having here a series combination. This is a parallel combination and parallel combination, then the equivalent are just connected in series. Okay, let's continue. What is the resistance of this combination? Okay, so this is 5 times 10, product over the sum, no? This is 5 plus 10. Since they are in series, you have to add the 2. So this is 6 times 8, 2 parallel combination over 6 plus 8. RT, okay? Let us have now the answer. So we have here 50 divided by 15 equals, so that is 3.33. Then plus, So we have 6 times 8, then divided by 14. So it is 3.43. So our total resistance would be 6.76. Okay, that is our answer. Okay, this is very easy. Okay, very easy. That is letter A. Okay, that is the answer. Okay, Sir Narciso, inaanyayahan kita, no, since NC2 ka, sa TESDA certified ka, inaanyayahan kita this coming Sunday. Okay, NC2 ka. This Sunday, yun ang mas appropriate sa iyo kasi ito, it's more of ang engineering ang approach talaga dito. Inaanyayahan kita sa Sunday kasi yun ang talagang pang master electrician. Mas maganda doon ka umattend. Libre din yon, no? Welcome na welcome ka doon every Sunday ng 9 to 12:30. Okay? Dito, of course, you can join here. Walang problema. No? If you want to, libre naman, no? Pero ang mas appropriate para sa iyo, punta ka doon sa sa Linggo. Join ka sa amin sa Zoom sa Linggo, ha, sir? Pwede ka ba dyan? Makaka-join ka?
Pwede po, pwede po.
Doon ka, sir. Maganda doon. Pang master. RNE ka na ba?
Hindi pa po. Mag-take
Okay.
pa lang.
Yun, bagay sa'yo yun. Doon ka sa master electrician. Kasi medyo higher level na yung approach dito, pang engineering kasi ito. This is a third year engineering level. I will be discussing the third year subject in electrical engineering, fourth year subject, third year, no? So we have the third year subject, fourth year subject, and the fifth year, meaning from direct currents, from electrical principles to power system. I-discuss ko po lahat yan. But it's a very long time frame. More or less 1 year. 1 year. Okay?
Nakakasunod naman.
Yes. Okay, let us, kumbaga, Sir Narciso, third year ka ngayon. Third year ka ngayon sa electrical engineering, no? Accelerated ka. Okay, next. Okay, sir, ha? Punta na po tayo dito sa number 8 problem. Okay, number 8 problem. For number 8 problem, a circuit consists of 4 100 watts lamp connected in parallel. So there are 4 100 watts lamp, no? They are in parallel across a 250 volt supply. Inadvertently, no? Inadvertently, ibig sabihin niya na hindi sinasadya, no? Parang ganon. Okay, in our language. Okay, inadvertently, a voltmeter has been connected in series with the lamp. Okay. The resistance of the voltmeter is 1,500 ohms. And that of the lamps, under the condition stated, is 6 times their value when burning normally. What will be the reading of the voltmeter? Okay. So, I will draw the circuit first. I will draw the circuit. So, we have here, what happened here is the voltmeter becomes in series with the lamp. Okay? There is a voltmeter here. Remember, a voltmeter has a resistance. Okay? So, let's say, this is our voltmeter. P sub M. It has a certain resistance, of course. Rm. So, that becomes, we have a lamp here, 1, 2, 3, 4. Okay. So we have 4. We have a source here of 230 volts. 230 volts. We have a 230 volt source. Okay? So, these are the 4 lamps. So, what we'll do here, we are given the wattage of each lamp. No? A circuit consists of 4 100 watts lamp. Okay. So, we have the power that is simply equal to V squared over R. So, what is our power? What is our power? We have 100. So, we have here our voltage, which is 230 volts. Then, that is squared, then divided by R. So, let us get the value of R here. What is the value for our R? Let us calculate. 230 x squared, then divided by 100 equals. So, we have here 529. 52529. Okay. Okay? 529. So, ayan yung ating resistance. No? It says in the problem here, inadvertently, a voltmeter has been connected in series. So, we have a voltmeter in series with the lamp. The resistance of the voltmeter is 1.5. And that of the lamp, under this condition, stated, is 6 times their value. Under this condition, the voltmeter becomes in series with the lamp. Okay? So, we'll be having here the 6 times. Let's say R prime. So, we have here 6 times 529. This is the resistance of each lamp. Huh? Okay? 529. That will be our resistance. So, that is 6 times 529 equals. That is 3174. 74 ohms. That is the resistance of each lamp for this condition. Then, if we are to find the equivalent resistance, let's say this is our R equivalent prime. We have to divide this by 4. Just like we discussed before. Identical, they have their resistances, right? Each lamp. So, the 3174, let us divide it by 4. Okay, so we have 3174 divided by 4. The answer will be 793. Okay? 793. 793.5 ohms. So, ayan 793.5 ohms. That is the R equivalent. Where is the R equivalent, by the way? If I have an ohm meter here, this is our R equivalent. Here, from this point up to this point. If you have an ohm meter to measure the resistance here. Of course, without the voltage source. Never measure resistance with the voltage applied. Okay? Never do that. I just want to show to you the equivalent. Where is the equivalent resistance? Okay? So, What is the question again in the problem? Okay, what will be the reading of the voltmeter? What will be the reading of the voltmeter? So remember that our equivalent resistance is 793.5. 793.5 here. Let us get the total resistance. What is the total resistance? That will be the 1.5 of the voltmeter plus the equivalent, which is 793.5. So our total resistance would be what now? 1500s, then plus 793.5. So the answer is 2293.5. 2293.5 ohms. Okay, this is our total resistance. We can get now the total current. The total current would be the total voltage, which is 230 volts. Then the total current, 2293.5. So what will be our total current? Okay, so we have here 230 divided by 2293.5, approximately 0.1. This is 0.1003.1. The question again, what will be the reading of the voltmeter? Okay, the reading of the voltmeter is V sub M by Ohm's law. By Ohm's law. Current, which is 0.1, times the resistance, which is 1.5. There you are. Okay? So therefore, simply, there is 0.1 that just move this decimal, okay, going to the left. One time going to the left. Okay, so we have here 150 volts. That is the answer. The answer would be letter. Let's see here. There you are. We have 150 volts. Okay? 150 volts. Okay, did you get that? Okay? So we have 150 volts. So it needs analysis. No? That's why in the other school, they call this as network analysis, no? This subject. I remember when we were in college, so there is, we have 3 circuit analysis subjects. We have the direct current circuits, alternating current circuits, and we have a network analysis. The network analysis, we will, our professor gave a more complicated questions. No? Although the principle is there, no? Nothing changes, but he is teaching us to solve, let's say, difficult problems. Okay. Let's have now number 9. Okay, I have to draw first our circuit for number 9 problem. A simple ladder network. So find the input voltage V which produces the current 0.25. 0.25 ampere in the 3 ohm resistance. All resistance are in ohms. So 0.25 ampere. Well, I have to draw the circuit here for number 9. This is quite a complicated circuit. 1, 2, there are 3 loop circuit. Question is the source voltage V here. What is the source voltage V? So we have here 7 ohms. So we have 5 ohms. We have 1 ohm. We have 3 ohms. 3 ohms. We have here 2 ohms. We have here 6 ohms. We have 8 ohms. 8 ohms. Then we have 9 ohms here. So it says in the problem that there is a current flowing to our 3 ohm resistor. This is the current that is 0.25 ampere. Is that correct? Find the input voltage which produces a current of 0.25 amperes. This is our 0.25. That is the 0.25 ampere in the 3 ohm resistance here. This is a series parallel network, a 3 loop. Okay? Okay, this is a network analysis. It needs a deeper analysis. No? This is quite a complicated problem. Okay? As we go along, no? From easiest to the hardest problem, we will be solving that. Okay, let us simplify the circuit. Okay, simplify natin ha, mga ka-aware pa. We have this 7, 5. Then we may replace this as one resistor. 1 plus 3, 4. Then this is 2. So we'll be having here 6 ohm resistor. This is the 6 ohm resistor. Okay, makinig ha. Listen everyone. Everybody listen. This is 6 ohm, this is 6 ohm also. Again, where did I get this 6 ohm? Because of the series combination of 1 plus 4. 1 plus 3, that's 4, 5, 6. That is the 6 ohm. Still, this is the 0.25 ampere. That is the 0.25 ampere. Remember that. Okay, there will be a current flowing here. Okay, this is our I total. That is the current delivered by the source. Okay. I will represent this as I1. I1. Take a look here, guys. Take a look here. We have our I1. We have a 0.25 here. By current divider theorem, we have 0.25 multiplied by the resultant current. Who is the resultant current? Our I1. Multiplied by the opposite resistance, which is 6 over 6 plus 6. Okay? So we can now solve our I1. What is our I1? 0.25 times 6 plus 6. So we have here 12 times 12, then divided by 6. So the answer is 1/2 or 0.5. I1 is 0.5. Take a look here. Actually, you don't need the current divider theorem here. Please listen. We have here our 0.5. Actually, they have the same value, 6 ohm and 6 ohm here. Meaning, the current divides equally. They separate equally. Okay? We may say if this is 0.25 flowing in the 6 ohm resistance, of course, they have the same. Because they have the same voltage. They are connected in parallel, right? They have the same voltage. Or just simply, if this is 6 ohm in parallel with another 6 ohm, if the current flowing is 0.25 ampere in this resistance, of course, there's also 0.25 ampere flowing here. Parehas lang yon. They're just the same. Kasi parehas silang value eh. Makukuha mo yung I1 kahit hindi mo na gamitan ng current divider. You can get I1, no, without using the current divider theorem. How? Of course, they have the same current. So 0.25 and 0.25. By Kirchhoff Current Law, the current entering at this node is equal to current leaving. That is the current entering, I1. So meaning that's equal to 0.25 plus 0.25, isn't it? So I1 is equal to 0.25 plus 0.25. So therefore, it is 0.5 of an ampere. Right? Did you get that? Right? Right, left? Right. Okay. So, let us get the equivalent of this. Of course, this is 6 and 6. No? You are thinking that they are identical resistors in parallel. We already discussed this before. Okay? We already discussed this before. Well, Sir Narciso, is this your first time? If this is your first time, I encourage you to watch, to view my video in YouTube from the first day, which is Electrical Principles 1, because this is already, if I'm not mistaken, I'm correct. Okay, if I'm not mistaken, this is day 7 or day 8 of our restudy. So it needs, as we go along, you really need to go back to the basic principles I discussed before, no? Because, well, it's just like going to grade 6. If you go to grade 6, directly, you are 6 years old, then you go directly grade 6 without going to grade 1 to grade 5. Especially nowadays, there is kindergarten. You have to go first to those level of education before you go to grade 6. So, kasi it needs a lot of basic principles. Okay, as we go along, pahirap ng pahirap yan. It's more difficult. Okay? So, I advise you, Sir Narciso, to go to our electrical principles in our YouTube. Actually, naka-arrange naman yun. No? It is arranged from the latest to the oldest video. Go to the playlist, Restudy Electrical Engineering, in my YouTube channel. Okay? And also, everyone who are watching right now, I encourage you, if you are first time in my channel, okay, your first time, go to my channel, no? Reggie Marina YouTube channel. Okay, I'll discuss that later. Okay. So, we have 0.5 here. 0.5. That is our I1. Now, we have 6 and 6. Of course, we all know that the equivalent of 6 and 6 is what? The branch resistance divided by the number of branches. 6 divided by 2. So, that is 3. So, I will put here the equivalent. We have 7. We have 7. We have 5. Okay. Then, we have here 3. Okay. This is now the equivalent. The 3, the equivalent of these two resistors. Okay. Then, we have here this one. And we have this one. We have the 8 ohm resistance, 7. Then we have 9. Okay, of course, we have a voltage source here. Voltage V. Take a look here, guys. We have here our I1, which is the 0.5 amperes. Ampere. Okay. This is our I1. Okay. As you see here, there is a total current here. But we have to find first our total resistance. So by the way, we have here 8 and we have 9 ohm resistance here. We have a 9 ohm resistance. Okay. Take a look here. We'll be having here 5 plus 3, so that is 8. Okay, so we have here, this is our 7. We have here our 8 ohms. Then we have our 9 ohms. And then we have here our another 8 ohms. Who is this 8 ohms? That is the combination of the 5 and 3. Because they are just connected in series, right? So 8. Remember, the I1 is the one flowing to the series combination of 5 and 3. Of course, this is our I1, isn't it? Okay? So this is very easy. This is 8 and 8. So 8 over 2. Again, branch resistance over the number of branches. Well, if you are first time to my channel, okay, so I'll show this to you. So that is equal to the branch resistance over the number of branches. So 1, 2, so that is 4. So we'll be having here 4 ohm for these two. Therefore, we'll be having here a 7. We have a 7 here. This is our 4 ohms. This is 7. And this is our 9. So we can easily get the R total. Isn't it? We have the R total. Okay. Let us replace the source voltage by the ohmmeter. Let us get first our R total. What is our R total? That is equal to what? I'll put it in here. R total simply equal to what? 7 plus 4, 7, 8, 9, 10, 11. 11 plus 9. Okay, that is 20. So, 11 plus 9. Tama? 20. Okay. See? I'm not good in mathematics. Huh? 11 plus 9. 20. Okay. You don't have to be very good in mathematics if you want to become an engineer. Although I'm an engineer, I don't consider myself very good in mathematics. I'm just an average math lover, no? Okay? It just need to love what you are doing. Okay? You don't have to be great for you to become an engineer. Okay? Well, of course, if you want to become the best engineer in the world, you have to be great in everything you do. Okay? It's up for you to explore those things. Okay. So, we have the R total, 20. 20 na yan. O, tingnan natin to ha. Take a look here. We have I1. Ilan nga ba yung I1? 0.5. We have 0.5. Again, By the principle I told to you, we have 0.5 here. So, I will make this as I2. What is the value of I2? Of course, they are just the same. Please close up this portion. Please close up. They are just the same. Parehas lang yon. Okay, dun sa prinsipyo yung tinuturo ko sa inyo. Just like I've told you before. They have the same resistance in parallel. Of course, they have the same current flowing. If this is a 0.5 ampere, this is also 0.5. Isn't it? So 0.5 plus 0.5, that will be your total current, isn't it? Your total current is simply equal to I1 plus I2, isn't it? Okay, I will put it in here. So this is our I total. So we have here 0.5 plus 0.5. So we'll come up with 1 ampere. So this is 1 ampere. Okay? So we already get the value. Now, let us get our source voltage. That is the total voltage that's equal to the total current, that is 1 ampere, times the total resistance, which is 20 ohms. 1 times 20, calculator? Okay. So, just put here 20 volts. That is the answer. Okay? Did you get that? The answer would be letter. Okay, there you are. 20 is the answer. Are there any question from our audience? Please, you want to clarify something? If you just want to clarify something, just ask, no? You may do so. Sir Leo, baka may tanong ka dyan? Anong tanong mo? Clear naman? Nakasunod ka ba dyan sa iyong trabaho? Nasa trabaho si Sir Leo. Okay lang? CK of TIPQC, do you hear me? Any question? Any question in this portion? What year are you in Technological Institute of the Philippines, Quezon City? What year are you?
Sir, 5th year.
Incoming 5th year?
Yes, sir.
Okay, so I hope you encourage your classmate, no? If you think you receive a quality lecture, so I hope.
Yes, sir. Yes, sir. I already sent it to the GC of my youth community in my student affairs, sir.
What's a no? What's a no? Okay, okay, thank you, thank you. CK, ha? Salamat sa iyo sa pag-anyaya mo sa mga kaklase mo. Yan, maganda, no? Nailagay
Sir,
daw niya sa
sir.
GC. Oh, may tanong ka? May tanong?
Sir, can I invite all the Metro Manila school chapters?
Of course! Invite everyone, even your professor.
Yes, sir.
Okay? You know why we are doing here? Because we believe that many, I can say majority, no? I can say, maybe what I want to say is, if you think you have that, when you were in third year college, no, you can't get the lecture of the way your professor delivering the lecture, you can't understand because he's teaching too fast. Then he will storytelling for majority of the of the time, so you can't actually understand that well. But in here, we promise you, no? Just listen, you will understand this. So my level of teaching is not that high. Okay? Not that high. Hindi mataas yung level ng pagtuturo ko. Maiintindihan to. No, basta't may foundation ka ng algebra. Okay? Kahit na kahit nga senior high, no, maintindihan ako. Basta nakikinig lang, no? Basta nakikinig. Pag hindi nakikinig, lalo pagtulog, no? Wala din. Okay. Sige, wala kang tanong? Do you have any questions, CK? What's CK? Calvin Klein?
Christian Kenneth, sir.
Christian Kenneth. Kapangalan mo pala
Yes,
yung
sir.
panganay ko. Okay, Kenneth. Sige, Kenneth. Wala ka bang tanong dyan?
Nothing, sir. Nothing.
Okay, nothing. Okay. Okay, let's go to the last problem before we have a break. Huh? In the circuit shown, again, there is a circuit. I have to draw the circuit. There is a circuit. Okay, I will draw first the circuit. Again, there is a series parallel network given. Okay, you may copy this, guys, no? Pat natin dito. Kenneth. Well, I advise you to watch the video over and over again so that you can master the topic or you may understand easily, no? It's normal when you attend the class for the first time you didn't get right away. That's normal. That's normal. Okay? I think the first time, no, in all aspects of life, the first time is the hardest. Okay? Because you have to adjust yourself. You have to adapt yourself. Okay? So if you are first time, you better see my videos on YouTube. Watch my videos so that you will learn this topic. This is very important in our electrical field. Okay, so we have 5 ohm, we have 25 ohms, so we have here 10, we have 15, then we have here 20. Okay. There is a question here. In the circuit shown, okay, last problem na po ito. Find the value of supply voltage B. Question is supply voltage B so that the 20 ohm resistor can dissipate 180 watts. 180 watts. Yun yung power. That is the power in the 20 ohm resistor. And remember that there is a current flowing here. We can solve now for the current flowing here. Let's say we have current I. Again, the question is the supply voltage B. That is the question. Let us get first our I. Okay, so our power is equal to I squared R. Our power is 180 watts. That is equal to I squared R, which is our 20 ohms. Okay, shift solve lang. Ilan ang sagot natin for our current? Okay, our current here is 3 amperes. So, 3 amperes. We have a 3 ampere here flowing through our 20 ohm resistance here. That is our current I. Again, just like before, we have here a current. Let us represent this as I1. What is our current I? Again, by current divider theorem, we have here our 3 amperes. That is equal to I total, which is, what is our resultant? Actually, not I total, the resultant current. The resultant current is the current that will be entering to this node. And also, this, if this is I1, this is also I1. By the way, this node, always, this is a purely parallel circuit. The 15 and 20 ohm are parallel circuit. Okay? This is the common node. If we are talking of parallel circuit, there is always a common node, two common nodes, two nodes. The upper portion and the lower portion. This is I1, this is also I1. Okay, so we have here I1, that is 3. Our I, by the way, is 3. Then we have here our I1, that is multiplied by what? So our 3 here, that is our I, multiplied by the opposite resistance, which is 15. Over 15 plus 20. Okay. So we have here our I sub 1. What is our I sub 1? Okay, so we'll be having here 7. Is that correct? That is 7. Okay, let us double check. So that is 35 times 3 divided by 15 equals. So that is 7 amperes. 7 amperes. That is our I1 here. Let us get the equivalent resistance of 15 and 20. Is 20 ohms. Okay, let us put it in here. This is 15 in parallel with 20 ohms. That is the product over the sum. Okay, 15 times 20 over 15 plus 20. Product over the sum. So we have 15 times 20, then divided by 15 plus 20 equals 8.57. 8.57 ohms. And of course, that should be less than 15, the smallest resistance, no? The value. If you will have more than 15 ohms, you are wrong. Okay? Always remember that. Your equivalent resistance must be less than to the smallest resistance in any branch in a purely parallel circuit. So this is 8.57 ohms. Okay? Now, that is the equivalent of 15 and 20. Let us redraw now the circuit. This is the circuit. Okay, so we'll be having here, this will be our 8.57 ohms. Okay. This is our 10 ohms. Then we have here our 5 ohm. And we have here our 25. Okay. That's it. So we have here our total current. And take note, we have here our I1. This will be our I1. We already have the value for our I1. Do we have that? Yes, that is 7 amperes. Okay. So, listen carefully, please listen. So, our 7 amperes, that is equal to what? I total multiplied by, okay, I total, that is the resultant current here because this is the node. Okay. We have here 7. Okay. That's equal to the resultant current. Again, the resultant current is the current entering to the node. And also that is the current leaving to this node, the lower portion. That is also I total. Always remember that. Okay. So we have here 7. That's equal to the resultant current, the current entering. That is also the current leaving at this node. Okay. Multiplied by the opposite resistance, which is 25. All over 25 plus. Of course, you have to add these two. Well, this is easy. 10 plus 8.57. So that is 18.57. Okay? So we have here 18.57. Oy, we can get now our total current. What is our total current here? So that is 25 plus 18.57 equals, then we have to multiply it by 7, then divided by 25. That is equal to, the total current is 12, around 12.2. 12.2. Okay? 12.2 amperes. Okay? 12.2 amperes. Do not copy it. No, please listen carefully. Okay? There is a possibility that sometimes I am wrong, no? Because that's the reality. No? But I have to correct myself, no? If I am wrong. Okay? There is no, this video has no editing. That is the difference. Okay? This is a spontaneous type of lecture. Okay? So we have here our I total. We have to get our total resistance. What is our total resistance? Okay, again, replace the voltage source by the ohm meter. From this point to this point. Papalitan mo yung voltahe mo. Yan yung ohm meter mo. Okay. Remember that this is 18.57 na naka-parallel dito, naka-series dito. So that is series combination, no? Series parallel. Uunahin ko lang yung 5. I will put here 5 first and then plus the parallel combination of these two. There will be two resistors in parallel. So what about? So that is 25 times 18.57. That is the product over the sum. 25 plus 18.57. Okay, please focus our camera here so that they may see that. Okay. Okay. Let's make it clear, this one. So that is over 25 plus 18.57. Okay. Okay, so we have here 25 times 18.57. 18.57 then divided by 25 plus 18.57 equals Okay, then that is 10.66, then plus 5. Because of the series resistor here, that is 15.66. 15.66. O, yan mga ka-aware pa. Yan yung total resistance. What about now the total voltage? The total voltage will be the total current. This is simply Ohm's law. 12.2 amperes times the total resistance. 15.66. So what is the answer here? So we have here 12.2 times 15.66. So the answer, let us round up to whole number because the choices is in whole number. So that is 191 volts. So that is our final answer. Okay, let's take a look here, guys. Come on, let's take a look. Okay, the answer would be letter A. Okay? See, 191 volts, no? Very hard. Oh, very hard. Okay? Is that very easy? No, sir, that's very hard. Okay. You need practice. You will not learn this if you don't practice in your own. Okay? You have to develop your skill sets. No? You have to develop your skill. If you want to become an engineer, you have to develop the skill of an engineer. Remember that. Don't just watch. Video is okay, that's good, but that's nothing if you do not apply. Always remember that. That's nothing. It doesn't work if you do not apply what you watch. You have to solve problems in your own if you want to become an engineer. Okay? Don't just read, no? You know, our course is not like other courses who love reading, no? That's not our course. Well, of course, we need to read, but read plus compute. You have to calculate because that is our course. Seen it? It's hard. Okay. So our engineering courses is one of the hardest courses in the world. When I saw, you see, hardest courses in the world, I saw in YouTube the top 10 hardest courses in the world. You will see engineering there in the top 10. No? So it's really need a lot of effort if you want to become an engineer. Okay? Work hard. Hard work. Work hard. Okay? So, okay, are there any question? Are there any question? Is there any question? Anybody in the Zoom class? How I wish we have 500 students in the Zoom class. Okay? What an impossible dream. So let's see. Let's see if that will happen. No? If God's permit, God willing, no one can stop it. Okay. So, are there any question? Paring Leo, Jess, CK, Narciso, nawala na si Sir Garcia. Okay. Any question? Oh, Caris. Any question? You don't have any question? Okay. So, well, if you don't have any question, okay, that's it for today. Okay, thank you very much. No? Hoy, there's clapping, yeah. Okay, thank you, thank you. Thank you. So, I hope you learn for this particular topic. But please do not leave yet. I will show you something to our non-Filipino audience. You may be benefited also to what I will show to you. Okay, that's my favorite animal. Animal. So, that's a lion. That's a lion king. You know, I love lion. I have a lot of lion in my That's my favorite movie of all time, no? The Lion King. Okay. We just watched it last year, right? Here in the Philippines. So, okay, because I can relate something. Okay. So, we have here, okay, this is a continuous, a very long study about electrical engineering for free. And we promise you, we will assure you to give you quality lecture. One of a kind lecture. No? Kakaiba sa iba. Angat sa iba. No? Papakitaan po namin kayo ng mga mas matitinding mga lecture. Tayo naman po kasi nagsisimula pa lang. This is just the beginning. Okay? The topic is just a fundamental. No? Maybe you will see some complicated when we go to complicated problems, when we go to machineries, to power systems especially. We'll go there. Most probably next year, God willing. Okay? So, let's see. Let's see. No? If God permits, no? We're still alive. We're doing fine. No? So, we just have to pray. No? Pray hard because it works. Okay? So, our free study electrical engineering, this is via Zoom. Okay? So, and via our FB Live. Actually, we just have a link in our FB. No? If the student will click our FB, the Marinais Powerhouse FB account, if they will click this, no, they will go directly to the YouTube live stream. And that's what we are doing right now, right? Okay? So, we will discuss all this topic for you guys for free. But it takes a lot of time to do this, no? This is a very hard thing to do, what we are doing. Very hard preparation, but sulit naman pagka nakita namin na naiintindihan ninyo. Because we want to help. We want to help. That's our primary purpose. We want to help. During this time of pandemic, no? This is the time of being compassionate with your fellow men, whether you are Filipinos, Americans, Europeans, Africans. Okay, we want to help students, electrical students around the globe. This is our impossible dream. Well, so be it. If other people would say to us, that's impossible. But we already have the first step. Okay. And the first step is the most important step. Okay? So, we have here our study electrical engineering. As I've said before, we will fix the schedule up to this December to MWF 9 to 12. Oh, it's already past 12 p.m. So, just give me a little more time. So, the Zoom ID will be posted in our FB account. So, please always look at our FB account, follow us in our Facebook account, that is, paki-close up natin to, the Marinais Powerhouse. Okay, paki-close up. Please close up this so that our non-Filipino friends will see it. You see, the Marinay is my surname, no? Is our surname of the board member of Powerhouse Review Center. Marinais Powerhouse Review Center. So, we have Marinais Powerhouse. Okay? Please close up this portion. Ayan, ito po, yung aming Facebook account. Please take a look, guys, no? So that you'll be updated. All announcements. Well, we are working. Sir, do you have a website? We are working on it right now. We're working on it. So, just have to wait, no? Okay, so for the meantime, we have this Facebook account. Then to our non-BSEE course, no? If you are electrician, just like Sir Narciso, he studied in TESDA, right? So technical school. So I'm inviting you to a free, again, this is free, Master Electrician Fundamental course. Sir, Narciso, maasahan ba kita sa linggo? Yan, tuturuan ko kayo ng paggamit nitong calculator. No? Babalik tayo sa basic mathematics. Ha? Ito, maganda, ma-appreciate nyo po yung ating mga nile-lecture. Kasi medyo, ano na ito eh, medyo malayo-layo na yung medyo na biyahe natin dito. So, this, I recommend to Sir Narciso to go to our YouTube channel to watch our previous subjects. Okay, so this is a Master Electrician Fundamental course every Sunday, 9 to 12:30 p.m. This is Philippine time. Okay, so we have the Zoom ID will be posted in our Facebook account. No? Free e-certificate at the end of the course. Okay, so then this is a very good news to everybody. If you attend our REE or RME, okay, by the way, so yung mga BSEE, hindi kayo pwedeng umattend dito sa ano ha, liban na lang kung all graduate kayo or old undergraduate. Kung BSEE graduate kayo, hindi kayo pwede sa Master Electrician. Dito lang kayo sa Pre-Study EE. No? Yung mga BSEE, currently enrolled students, dito kayo. Okay, you can enroll here. No? Even though this is free, there is enrollment, pre-enrollment. No? That is pre-enrollment. There is registration form. Okay? So, you will have a chance, no, to be a scholar in our electrical engineering or master electrician regular review and refresher course for April 2021 board examination. So, if you have a very good attendance, you have a big chance. Okay? You have a big chance to become a scholar in our regular review this coming November. Okay? Actually, what we are doing right now is not a review. This is not a review. This is a study, a long study. Review is different. It's quite compressed. The lecture is compressed. Any review center is like that. Okay? Because that is devoted only for licensure exam. What we are doing here is not only for licensure exam, but this is also for the school. If you are a student, this is very useful to you also. Okay? Not only for board exam. Well, ang maganda dito sa ginagawa namin, yung mga example ko, marami po akong papakita mga pang-board exam. Yun ang maganda. Because we are a review center. Okay? Wala sa ibang libro, yung iba nasa ano, no? Sa board exam base. Okay? Then we have our pre-webinars. Well, actually, this is in Taglish. This is a pre-webinar. Okay, so this September, so I'm inviting everyone. So this is in Taglish, no, our language. So I'm encouraging everybody to attend this, no, our webinars. Then this is our special webinar. So the difference is, so this has a payment. Okay, you have to pay before you attend for this special webinar. This is a free webinar. Okay. Free webinar, libre ito, no? Ito kasi may bayad. Okay? Ayan po. Then good news for the student like CK. CK, no? Good news for students, we will be giving 70% discount. Meaning, per topic is 1,500, you will only pay about 450 pesos. That is less than $10. That's very cheap, no? It's very cheap. Okay, so this is 70% discount for students, no? Okay, yung mga hindi naman estudyante, 1.5 per topic. Murang-mura pa rin po, no? Magsisimula po kami this coming Saturday, no? We will start this Saturday on our, particularly to our building wiring installation, no? Pwede nyo pong i-avail, no? Kung anong gusto ninyo dyan. the building wiring installation. We have industrial motor control. We have the practical electrical estimation course. This is an estimation. This is a very practical in approach. Very nice course. Very useful in the field. And also this, no? This is what I say, shall I say here? This is a very important topic to all, especially future electrical engineers, no? Even though you are already an engineer, no? If you want to attend our practical electrical design course, so that will be, it will start this Sunday. Okay, just please take a look at the details of this in our Facebook account. Okay, so we have the power system engineering, the high voltage engineering. So we have this from September 5, 12, 19, and 26. Okay, so that is 12:30 to 4:30 p.m. Okay. So, well, this is the detail of the course outline, no? Because there are somebody asking, sir, what is the coverage of this training? This is special webinar. So, this is the coverage. Okay. So, we can send this to you if you are interested to enroll to our special webinars. Okay. Sisimula po tayo dyan sa Sabado, no? Okay, industrial motor control. Meron po tayo. Yan. Kaya lang sa ngayon, hindi pa po tayo makapag-conduct ng actual, no? So, it's a webinar, no? It's an online webinar. Okay, so, but what we did is, I did a simulation, no? A diagramming so that you will learn, so that if you go to industry, you will not find difficulties connecting these contactors, relays, no? Circuit breakers, okay? So, this will help a lot in your field, not only for board exam, but also for work. Okay, this is the electrical estimation course. Very cheap. It's only 1,500. Very cheap. So, I will deliver that to you online. Okay, the electrical design course, it's a must for future electrical engineer and future master electrician. Because if you are a master electrician, you have to implement the design. During the construction phase, construction period, you have to implement the design. You should know how to read and know some basic calculations if you are a master electrician. Very important. Master electrician, you can also design. You can also design. As long as it is 500 kVA, 600 volts. That's your capacity. And you have an engineer guiding you in your preparation of the electrical plan, so there will be no problem. You can also do the design if you are a master electrician. So I encourage you to attend here. Actually, we already gave 1/3 of our webinar for free, and that happened yesterday. And there is a continuation every Tuesday. That is about the high-rise building electrical design. Okay? So, that is in Taglish, Tagalog, English, setup. Okay? So, I'm inviting everyone, to all our Filipino students, practitioners, I'm inviting you to attend this. Okay, then we have a power system engineering course. So, these are the course outline. Okay? We'll just give that to you. If you are interested, we will send this to you. High voltage engineering. Okay, so we have an early bird promo. So, mga kawerpa, meron tayong early bird promo, no? Ito yung ating promo. 50% discount. So, 9K lang sa REE hanggang Thursday, no? 9,000. Review and refresher course na yon, 9,000 pesos. No, if you are master electrician, 8,000 lang review refresher. That is around 50% nung presyo namin noong face-to-face. So, 50% lang po ang babayaran ninyo. So, murang-mura lang. No? We also have a master plumber review. Ay, mas mura yon, 7,000 lang. If you will pay in cash this coming Thursday, September 3. Pwede rin naman installment, kaya lang madadagdagan ng 2,000 pesos. So, yung REE magiging 11,000, RME magiging 10,000, Master Plumber will become 9,000 pesos. But you have to pay 2,500 down payment on September 3. Okay? So, you will avail. And then the balance is payable on the first day of the review class. This is for next year. For RE, RME, April 2021 board examinations. No? So, Master Plumber for February naman yan. Okay, so we are selling our review materials for registered electrical engineer. Okay, so that is amounting to 3,600 pesos. The package, the 4 books. Okay. These are updated lectures, no? From 1990s up to present licensure exam. So, we compiled the licensure exam problems, no? So, these are past and possible board exam questions. Okay? This is for Master Electrician, 2,600 lang yan, no? Okay, for Master Plumber, 3,100. Okay, everyone, no, to our non-Filipino friends who are watching right now. So, again, my name is Engineer Reggie Marinay. This is also my YouTube channel. So, please come in to my YouTube channel. Please subscribe, like, and comment. Even comment. Everybody who are watching, I hope if you will watch this again in YouTube, please put your comment. Okay? Kasi yung iba hindi nagko-comment. Please put your positive comment if there are, no? Okay? If there is negative comment also, you may do so. Okay? You may do that. It depends on the student. If you find it good, it's up to you. Okay? So, study electrical engineering the Filipino way. Okay? So, because I am a Filipino, my mother said that I'm like an Indian. So, because I saw a lot of Indian professors giving lectures in electrical engineering. No? So, I'm not an Indian. I'm a Filipino, 100% Filipino. Okay? So, because I had a dark skin. Okay? So, also. So, with this, I should say, thank you very much, everyone. So, I hope to see you again tomorrow. Okay, thank you. God bless you all. Maraming salamat po. Thank you.